This is Thursday the 19th of January 2017, and just a quick recap on what we've done so far. It was all about parametric equations, and a parameter is a third variable which connects your x and y, and we've also converted from parametric form, and we've written our equation in a Cartesian form. So that means eliminating t to get y in terms of x. So please turn to page 5 of your booklet, and I asked you to finish off question 3 and 4 for today. So if you could look at the answers that you did for question 3 and 4 for today, please, you can see that the key statement in each of the questions, for question 3, it passes through the point 40, so you use that y was equal to 0 and you had the x equal to 4. It allowed you to find out what t was, substitute it into the x coordinate, the parametric form, and you get what a is. Question 4, very similar. You were given the point 0, minus 5. Substitute in x equals 0, and that allows you to find out what t is. Substitute t and y in, and then once you have these two values, t and y, substitute it into the y coordinate, a bit of rearranging and numerical work, and you get b equals 4. This is example 5, which is on page 6 of your booklet. We've got a curve is given parametrically by the equations x equals t squared and y equals 4t. The line x plus y plus 4 equals 0 meets the curve at A. Find the coordinates of A. So we have the equations x equals t squared, we'll call that equation 1. We've got y equals 4t, we'll call that equation 2. And then we've got our third equation, x plus y plus 4 equals 0. We'll call that equation 3. So what we need to do is substitute 1 and 2. We need to substitute 1 and 2 into 3, and that will allow us to find out the value of t. And once we find out what t is, then we can find out the x and y coordinates of A. So taking x, it's t squared, and y is 4t, and this produces a quadratic in t. If we factorise it, and that means that t is equal to minus 2. If you notice, that actually happens twice. If it happens twice, then we're looking at a tangent, or it just touches the curve. So from there then we can find out the x coordinate. So x is equal to, we now know that t is equal to minus 2. So t is equal to minus 2 squared, so that's 4. And we've got y is equal to 4 times minus 2, so that's equal to minus 8. So A must have the coordinates 4 minus 8. So on exercise 2b, I'd like you to do questions 7, 8 and 10. And if you stop the video now, take about 5 minutes or so to do the questions, and start the video again, and then I'll have the solutions for you. So looking at the answers for questions 7, 8 and 10, we have the first one fairly straightforward. You've got linear equations, and the point of intersection is half 3 over 2. On the next one we've got quadratics going on, so we factorise with a quadratic in t. So we've got two values of t, then we have to find the corresponding points of intersection by substituting them into our x and y equations, parametric equations. We then move on to question 10. Could you check your answers there, please? And this time it's a little bit trickier. We do have a quartic here. It comes out to be t to the 4, but we can still factorise it as we would do with a quadratic, and it becomes lots of answers because you're taking the square root, so you have to consider the positive and negative values here, and then if you put these values of t back into the originals, then the points of intersection are 4, 4, 4 minus 4, 1, 2 and 1 minus 2. We're going to take parametric equations and we're going to turn them into Cartesian. So parametric, as you know, that's where we have t's or a third variable, and a Cartesian equation, it's y is equal to some function of x. So what it's asking us to do is, if we have a look at our key phrase, this parametric equation we've got here, we want to turn it into a Cartesian, so that actually means eliminate t. Okay, let's look at part A then. We've got x equals sine t plus 2, and we have y equals cos t minus 3. This brings in your trig from C3, and what do we know that connects sine and cos? Because we want to get rid of the t altogether. So thinking about, this is actually from C2, not C3, it's cos squared theta plus sine squared theta is equal to 1. If we call this one equation 1 and equation 2, then it's a little bit like the r cos theta in trig C3. So if we square them and add them, then we're actually going to get this identity here, which we can then eliminate t. Let's have a go then. So if we take 1 and we square it and we add it to 2, we get we have to rearrange number 1, so that's going to be x minus 2 is equal to sine t, and if we take the other one, it's going to be y plus 3 is equal to cos t. So if we now square them and add them, we get x minus 2 all squared, that's minus, plus y plus 3 all squared, and that's equal to sine squared t plus cos squared t. So that gives me x minus 2 all squared plus y plus 3 all squared equals 1. Now you should recognise that from C2. We have a circle, and it's a centre of 2 minus 3 and a radius of 1. So that's part A. Can we now do part B? So let's have a look at what that would be like if we draw it. We've got a centre. So we're going to, we've eliminated t, which is the parameter. We've now got Cartesian coordinates x and y. So it's centre, if I make that 1, 2, label. So it's centre 2 minus 3 and a radius of 1. So it's going to look something like that. Right, what I'd like you to try now in the same way, so you may have to look up some of the trig equations identities from C3, but on exercise 2C I'd like you to do question 4 and question 5. If you stop the video now, have a go at those and then I'll put the solutions on for you. Exercise 2C then, question 4 and 5. So question 4 was very similar to the example. What we've got here is a rearrangement of x equals sine t minus 5 and y equals cos t plus 2. Rearrange them, square them and add them and make it a circle, centre minus 5, 2 and a radius of 1. Looking at question 5, we should have in this case also divided by 4, the same procedure, square and add, then multiply by 16 at this point here, and then we still get a circle, centre 3 minus 1 and radius of 4. Right, turning to page 9, we're looking at example 7 now. And this is going to be using our C3 trig, and what I'm hoping that you would have discovered or spotted is that we've got an x equals sine t and a y equals sine 2t. So that should say to you straight away the double angle formula. So find the Cartesian equation. So again we want to eliminate t. So we've got to try and get rid of our sine 2t and our sine t in some sort of way. So if we take our y equals sine 2t, we can apply the double angle formula and we can say it's y is equal to 2 sine t cos t. Now we've got a little bit of problem here because we don't have anything in terms of x or y that's a cos t, but if we think about from C2 and another trig identity that we've got, we need everything in terms of sine t. So if we take cos t is equal to the square root of 1 minus sine squared t, all I've done is taken sine squared t plus cos squared t equals 1 and rearranged it to make cos the subject. So we can see there from our cos t it's actually equal to the square root of 1 and x is sine t, so it's 1 minus x squared. That's what we're looking for there. So going back to our y, we want to eliminate these, the sine t and the cos t completely. So that's going to be 2 and sine t is x and cos t from a rearrangement is 1 minus x squared. And what we've done there is we've taken a parametric equation which links x and y with t, and we've eliminated t using our trig identities. What I'd like you to do is to try question 3. It's on the same vein. And again, I'll pause for a few moments and you can see if you can. So that was exercise 2C, question 3. Welcome back, and here are the answers to exercise 2C question 3. We're looking at all parts here because you need to be able to manipulate the trig functions, the trig identities. So I'll give you a moment to mark your own work. If there's any problems there, please note them and we can go over them in class tomorrow. Right, the next that we're going to do is finding the area under a curve given by parametric equation. So as you know, an area under a curve, we need to do some sort of integration. We have a formula here, and the area under the graph, if you've got x and y connected by the parameter t, you have to apply the chain rule, which means that we have this formula and it's not given, so you have to actually memorise and learn that. That is not given and it crops up quite often in C4. Let's look at the first example then. We've got a curve with parametric equations x equals 5t squared and y equals t cubed. Work out the area under the curve. Okay, and it's all with respect to t. So if we take our y dx by dt, and it's in between 1 and 2. The only thing that we don't have there is dx by dt. So we've got y is equal to t cubed, and we also have x is equal to 5t squared. So using our formula, we need dx by dt, which is equal to 10t. We now take those two parts and we can put them into our integration. So that's going to be in between 1 and 2. Y is t cubed and dx by dt is 10t. We simplify that first of all. So that gives me the integral between 1 and 2 of 10t to the 4, and that's with respect to t. So we integrate, add 1 to the power, divide through by the new power, in between 1 and 2. This simplifies, so that's going to give us 2t to the 5 in between 1 and 2. So upper limit first, 2 times 2 to the 5 minus 2 times 1 to the 5, the lower limit, and that's 64 minus 2. So we've got an area under the curve of 62. Moving on to example 9, we've been given a diagram in this one, but it's the Cartesian diagram, and the equation that we've been given is the parametric form of x equals t squared and y equals 2t with a bracket 3 minus t. The other thing to note is that t is greater than 0, so we're going to have to find limits, because as you know, we have to satisfy in between upper and lower limits of y dx by dt with respect to t. So these limits have to actually be t values. So what we've got from our diagram are x values. So this is when x equals 0, and at that point there it's x equals 9. We've got the Cartesian equation for x, so x is equal to t squared, so that implies that t squared is equal to 0, so t is equal to 0, so that's our lower limit, so we can put a 0 there. And when t squared is equal to 9, then t is equal to the square root of 9. Now, as I highlighted, t is greater than 0, so t must be equal to 3. We don't take the negative one, so the negative root of 9. So from 0 to 3, and y we know as 2t 3 minus t, and dx by dt is equal to 2t. So again, that's multiplied by 2t with respect to t. So we have to tidy that up a little bit. And when we do that, it's in between 2 and 3. It becomes 12t squared minus 4t cubed dt. Right, when we integrate, it becomes 4t cubed minus t to the 4, and that's in between 0 and 3. If we now calculate that, the upper limit first of all is going to be 4 times 3 cubed, and subtract 3 to the 4, and then on our next one is going to just be 0 minus 0. So the full area for this is 108 minus 81, which gives us 27 units squared, because it is an area that we're dealing with. Well, the questions that I would like you to try from this are exercise 2D, and it will be questions 2, 4, 6, 8 and 9. If you spend a few moments on that, that's going to take you quite a little while, but what I'll do is, if you pause the video, and then I'll write the numerical answers, and then we can see where we go from there. Welcome back. The solutions, there's the numerical solutions for you there, and then we want to finish this chapter completely, so what I'd like you to do is to hand in on file paper, and that will be for next Friday, which will be the 27th. So move on to the next slide on exercise 2D. That's what you've just done. So question, the next of the booklet, and on the front cover you'll see things that you need to remember, and on the area under a curve under point 4 you will need to be able to state the equation for area under a curve using the parametric equation. So that's got to be done by memory. So we'll stop there. That's us finished chapter 2, and you can complete those questions for next week, please. One is 2E, it's a mixed exercise. What I'd like you to do is hand in on file paper. Friday, the 27th of January 2017, and that's questions 1, 3, 6 and 10. That's the end of this booklet. What you might like to do is go back to the very beginning